dive in. And I did not get a chance to make your start. Well, actually, we'll pause this and I'll pass on. So yeah, we studied roots. Sorry, Lily, feel better if you watch the video. If you don't, understandable, because when I'm sick, I don't want to do schoolwork. So our root word circum right here, that tells me around. And this is a manipulation of a distance or a length or a measurement. So my circumference is just the measurement of around the circle, which is going to be distance because we're talking about two-dimensional shapes that have distance around them. So, pi. Now, we all talk a lot about pi, and I actually am quite depressed that most people have no idea where pi actually comes from. They're like, oh yeah, it goes on forever. For a second, I thought you were going to pack of cigarettes. I don't like, so I glanced over, and of course I didn't think it was real, but this, just how it was lighting, I was like, what is she, what? Just got very concerned for it. But like those candy, you know, have you ever seen the candy gum cigarettes or something? I was about to be very surprised. Pi. I want you to know this. And I want you to take it through your life and spread this knowledge as much as you can. Pi is actually generated from a division. This is why it's endless. You remember doing long division? When you're like, God, when will it ever end? I just keep going and I keep getting decimal places and I can't. And eventually, hopefully, you find zeros and your long division ends. The long division for this never ends. Pi comes from the distance around the circle divided by the distance across. So if you want to write an approximation for this, or what we could kind of like nickname it, pi is the ratio of around compared to across. It's the distance around compared to the distance across. And of course that distance across has to be through the middle. You can't just go like across a tiny bit of it. And that is your circumference divided by your diameter. There are supercomputers, computers all over the world that are continuously doing this long division when they go to sleep. Like these computers go to sleep and they do nothing. Computers at Otterbein would go to sleep and run these math problems. They're millions and millions of places into the decimals. There's no end. And there's enough proof to show that the system of division has not yet generated a pattern, and therefore we have so many places, it is assumed that it will never create a pattern, which means if it doesn't repeat and doesn't terminate, that's why it's an irrational number. So remember, pi is an irrational number, but we use it because we have an approximation for it. Abby?
When we were in like 5th grade, we read a book from like pretty much kind of how pi came from, but it also said how it also like shared how like the name diameter and like circumference came.
Yep.
It was like somewhat like people were like named diameter or something, and someone got like sick. And it's a long story.
So one application of this, like why do we care about this stuff? When I went down last month for my heart stuff at OSU, one of the things they do, the measurements they take, is the diameter of my aorta. The distance across it. How wide is the thing that pumps your blood? It's supposed to be a certain width, going with like your body size and everything else. What an aneurysm is it's wider than it's supposed to be, and the wall of your vein or your aorta is thinner than it's supposed to be. So that wall is thinner because it got wider due to like blood pressure spraying and hitting it and whatever. It's all fine. Like it's all been the same for the past 8 years that we've been watching it. But that's applications of this. They literally look at the aorta and measure across it. It's really kind of cool. You get to see your heart in 3 dimensions, and it's kind of cool. So, approximations of pi. You guys all know the decimal approximation for pi probably. What do we use?
3.14.
3. Yeah, and so if we keep going, which this is a good time to talk about Pi Day, is March 14th. We have a Pi Day contest. If you want to start working on memorizing pi, there's pi sheets out in the hallway. But we normally just talk about 3.14. Now, there's also a fraction approximation. That fraction approximation is 22 over 7. Because if we do 22 divided by 7, here's the decimal that we generate. 3.142857. So if we compare the real pi, 3.141594, yada, 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 our decimal approximation, 3.14. I think someone's on the roof. I'm not joking.
The roof is shaking.
3.142857. If we take the differences between this, well, this is off by 1,594, so my difference would be 0.001594, and the difference here, I'd have to flip these and do the subtraction, but this would be 0.0013. It's actually closer. So the 22 over 7 is actually closer to real pi than 3.14. But if you use 3.1415, then you're closer. So it all depends on where you stop. Do you stop at 3.14? Do you use the fraction? Or do you use actual pi? There's a button on your calculator for pi. That puts into your calculator pi to so many decimal places, your calculator can barely handle it, and it will round before that ever matters. Because you only fit so many on your screen, but it has 50 decimal places or 100 or something stored in its brain, and it just plugs it into your problem. So that's the most specific, closest way to get the real answer. Question? Because it can't be another story. We got to keep moving.
I've gotten 3.14.
Okay, so questions. Any issues with knowing pi is 3.14? We approximate it. It is irrational because it goes on forever. So how do we get our circumference? We have these two formulas kind of tucked in here, kind of small. Please rewrite that over here in the box that says formula. I'm sorry this is shaking around so much. Somebody's doing work on the HVAC system. So we actually use pi times our diameter, or I can replace diameter how else can I find diameter? Andrew? So I could replace the diameter with 2 radiuses. So that's how I get 2 formulas. Yeah, 2 radii, thank you. So I can either use pi times diameter or pi times 2 times r, which a lot of times we then put the 2 in front, and we would say circumference is 2 pi r. But the reason why is because we replace diameter with 2r. Any questions on those formulas? And this formula comes out of the relationship that pi, should have known that was going to happen, that pi is the circumference divided by diameter. If I multiply both sides by diameter, I get circumference by itself. Then I have circumference by itself. That's what I wanted. Any questions?
So I might be way ahead of what we're doing, but if you were to solve this, would you divide by pi?
Solve for what? What would you be looking for?
I don't know, if you were to do the normal distributive.
So it depends on what we're trying to do. So stick with me for a problem or 2 more, then see if you solve a question. So when we're given the circumference, this goes back to what I said yesterday, why I love circles, why they're so nice. Given one piece of information, I can calculate everything else. So if we're given the circumference, we can actually use that to figure out all the other information about the circle. So on your paper, you probably have it right here, and you can use it. That circumference is pi times diameter. So if I look here, well, we have circumference equals 3 times pi. M is meters. That's your label. That is not a variable, not anything else. It's a label. So that would tell me what else about the circle. If they're saying circumference is pi times 3, and we said circumference was pi times d, Abby?
Isn't 3 the diameter?
The diameter here is 3. Meters specifically,
Okay.
because we have those labels. So we use this. What about my other circle? Hayden, you know the diameter over there? Yeah, my diameter would be 4 because they have 4 times their pi. Now, if we know our diameters, we can also generate our radius because we know that radius is equal to half the diameter. So, Jack, if my diameter is 3, what would my radius be? So my distance all the way across the circle is 3. I want the distance half the way across the circle. Close. Chop. Break your 3 up into 2 and 1. So 1.5. So just be careful. Simple mistake because you're not using a calculator or anything. Totally fine. So our radius there would be 1.5 meters, Xavier. Radius here would be 2. And the other ones are tricks. Those boxes do not get used. We can also then generate the area, but we're not there yet. So don't worry about that. Yeah.
So when D equals to M, couldn't that be over there for 4M? Because can it?
Because this is circumference equals the diameter times pi. So here's our pi. Same. What is the diameter? The number multiplied by pi. So the diameter is 4. The radius is 2. Remember, if we think about a circle, the diameter of 4 is all the way across. The radius is just from the center out. That's 2.
Oh, so it would be 8, not 4.
What?
I mean, if the diameter was 2.
But it's not. These don't match either of these problems. They're distractors. They do not match. So you can cross them out if you need to, but we did not use them. They do not match either of the circles that we have. This was like your answer bank. Any other questions? So Abby, if our diameter was 2, that would mean the distance all the way across was 2, and that would mean the radius would only be 1 there. Because the diameter is all the way across. If the diameter was 2, the radius would be 1. If the radius was 3, then the diameter would be double that, and that would be 6. So we can either half or double, depending on which we're trying to find. And this will get a lot easier after you do some practice on it. After I remember to actually post it on Schoology. So we have a diameter of 4. When you're choosing your formula, look at what do I have? Well, if I have the diameter, use your diameter formula. Start by writing your initial formula. Then fill in what you know. So we know that diameter is actually 4 here. We know that pi can be replaced with either of our approximations. So yeah, decimal is what most people go for. 3.14 times 4. So our circumference here is going to end up 12.56, I believe. And we have to label it with the label used for the other distances. Diameter was inches, so our circumference is inches. Sweet, thank you.
I just have like a question in general about circumference.
Okay.
Like, I know, like when you measure, like you can't like measure a box and get pi, but like, so if you
Only
measure
works the circles.
a circle and you get circumferences, isn't it? You can get pi with like all like circles. Just
So say you were
when
standing
you,
at a
like,
lake.
don't get pi, you pretty much like.
So So say you were standing at a lake, right? Let's say you walk all the way around the lake and you keep track of exactly how far you went. And it's a perfect circle. It's like man-made probably. Or a pool. That distance divided by, then you swim across the pool or lake or whatever.
Swim like that.
So the distance around divided by the distance across, that division would generate pi.
But if it did not become pi, then you probably...
Then it wasn't a perfect circle.
Yeah.
So if it was like an ovular pool and you tried that, that wouldn't work.
Or you just didn't do your division or multiplication right.
Or that. But we're assuming we did the math right.
Yeah.
Any questions? Here's another trick to help you remember this formula. When you think about circles, what's probably the first food to pop in your head?
Oranges.
Pizza
Pie.
or pies. We're talking flat though, so be careful. Oranges are more like spheres. So they are round, they are circular, but that's a sphere. So,
A cookie.
so like orange slice, we could slice a circle out of the orange. But think about a pizza.
Oh.
What on the pizza would be the circumference? The crust, right? So the crust, let's jot this down somewhere. I'd go to the back. The crust is equal to, and another name that we can call pizzas is pizza pie, right? Because it's actually a pie. So the crust is your pie. It's your pie dough, right? The crust is pie dough. So your circumference is pi dough. C is pi d. Crust is pi dough. Circumference is pi times diameter.
You in your class and you said you weren't that cheesy or corny with those jokes.
My pizza's that cheesy. That's how bad I am. No, but look, you're lucky that I'm not showing you this one video about circles where the song gets burned in your head for like days. It's so bad. If we get through the rest of the lesson, we'll maybe watch it, but it is so bad.
I want to find it and make my mom listen to it.
It's literally just called like the Circle Song or something
Circle,
like that.
circle,
It's
circle.
not. Stop. So now, we're given circumference at 6.28. We're asked, what effect does doubling the radius? Well, crap, do we know the radius right now? So we have to first derive our radius. So let's work our formula. If circumference equals pi times diameter, and I know that circumference is 6.28, let's set this up and work vertically. So that's going to equal pi times diameter. How would I get diameter by itself here, CJ? What do I need to get rid of and how do I do it? How do I do it? Now, if we think about pi as 3.14, this will give me an answer of 2, which then tells me that my radius is equal to, how's the radius compared to the diameter? Half of it, half of 2, is just 1. So this distance is 1. Now, let's imagine, what if we doubled the radius? What if we had a circle with a radius of 2? Now we can then calculate the circumference, but I don't have to work through everything because I have another formula that I could use. I could use my circumference formula that involves the radius. What's that formula that involves the radius? Do you know my formula?
Isn't it
I don't want a question, I want an answer.
radius times 2?
That's how you get diameter.
Oh, wait. It's radius divided by half, right?
Well, that's still times 2. Dividing by half is multiplying by 2. Xavier?
Isn't circumference equals pi times 2?
Instead of diameter, we can use 2 times the radius because 2 times the radius is diameter.
Hey, at least I tried.
So we set this up. My radius is 2, so I really get 4 times pi. Well, that's exactly what we had on the front. So now our circumference doubled. So hypothetically, we're going to say whatever we do to the radius, like multiplication wise, that's what happens to the circumference. Think in your head, does that make sense? And don't, like, I think a lot of you guys, when teachers ask questions, you're thinking, like, oh, this is probably a trick question. But, like, if you think about that lake or that pool or whatever, as the distance across it gets bigger, will the distance around it get longer? Yeah. So if the distance across it doubles, well, so don't just think about radius, think about diameter. If I'm standing on one edge of the circle and the other edge of the circle's there, and then we double that circle size, did I double the distance around it? Well, right now, yeah. If we want to test it one more time, you don't have to write this down. But what if we double the radius one more time? Sorry, double this. So instead of 2 times 2, do 2 times 4 times pi. Somebody try that. Do we get an answer that is double our 12.56? So we should get approximately 25. Is that what you got, Xavier? If you do 8 times pi instead of 4 times pi?
Wouldn't it be like 25
Oh, so then you would have to hit frac def or def. Your calculator is just set to give you answers in terms of pi. So if it gives you something that you don't like and you want to convert it, on these, your fraction decimal button is there, so you have to hit second fraction decimal. It might give you that. It's stuck generating that, so we'd have to go into mode. We have to go to scientific. So it's because you typed in pi to begin with. If we just do 8 times 3.14, I'll switch you guys.
Me and my sister were in math class together, and we got the closest thing to pi in our whole math class.
Yeah. So if you're using the yellow calculators and you use the pi button, your answer is going to be stuck using pi. So please type in whatever approximation that you are wanting to. And that does work. That always holds true. So whatever you do to the diameter, we're doing the same thing to the circumference, that distance around. Try, because this is a problem just like from your homework and just like from our mastery. If you think about one rotation of a tire, well, if you've never thought about this before, you go as far as the tire's distance is around. So, if our tire is rotating, we're going to go that far. I'll be right back.
No teacher, revolution.
Wait, I saw something happen with one.
Oh, this is on video. Yeah, this is on video. Dab up there. It said, no teacher, revolution. Go dab, I dare you. Yes, but this is on video. Dab.
Dab right
I actually just want a paper.
Justin will do it because Justin was there. Justin. He's probably not gonna edit it
So
out.
you're working control.
No, Mr. Hudson doesn't edit any of his videos out.
Who's got it?
I don't.
Why do I see so many blank papers? Why is it that when I challenge you to solve a problem and then I walk away, we can't do it?
It's confusing.
No, you have the formulas. You have everything that you need. You're just not putting any effort in. Which I'm tired of. It's February. Either invest and put effort or get out. If you don't want to do this, there's tons of videos out there, Khan Academy, everything else. You don't want to do this, you can go teach it to yourself. But if you're in here, I'm expecting that you're going to put effort into this. I should not have to be right over top of you for you to do your homework. I should not have to remind you day after day after day that late assignments need turned in. I should not have to do every problem for you because that's not good learning. So when I ask you to do something on your own and I come back and over half the papers are still blank, why wouldn't we even have a formula written down? Start with what you know. Start filling in what you can. Abby, please put that away. We've talked multiple times about how that stuff is not supposed to come to school anymore. We are talking about distance around the tire. That's circumference. So our formula, circumference is pi times diameter, or crust is pi dough, if you struggle to remember that. So I can then fill in, it tells me use 3.14. So replace pi with 3.14. What else do I replace or substitute in? Casey, what else? What's the image show me? What is the image? The picture show me.
Tire that's 20 inches.
It's 20 inches across. So that distance all the way across is 20. What do you get?
Wait, the distance all the way across?
Yeah.
Oh, okay. Didn't see that.
Yeah, sometimes when it prints black-white, it's a little hard to see, so that's why I always reference up to here if you're looking for colors. Xavier?
1630.
Is that rounded to the nearest tenth?
Yeah, it's 62.8.
So we, to the tenth,
Oh.
we put in that 62.8. Because we want to go to that first decimal place. So every time that tire spins, you go 62.8 inches. If we get done with this, remind me to tell you the story of my speeding ticket. Has to do with math. When we get done with this, remind me to tell you the story of my speeding ticket, or talk to me at lunch. I think I actually get to eat lunch today. Yesterday I did not. To the nearest tenth of a meter, so round to that first decimal place. What's the circumference when the radius, you guys are trying this on your own, the radius is 3.4. Be careful, because we can't use that crust equals pi dough formula unless I find the diameter or use the other formula. So I have two options. I can either find the diameter first and then use my one formula, or use the other formula and use radius. So Andrew, I don't want answers or anything, but what formula are you using here?
I'm using pi equal, I'm using the circumference equals pi times 2r.
Yeah, so you're gonna go ahead and use this value. And again, they tell us use 3.14 for pi, which is our standard approximation that we use. You'll occasionally be asked to use the fraction just because it's better. Is anyone using the circumference equals pi d formula? You are, CJ? So what'd you do first then? Before you can plug in for d, you gotta find d. How'd you do that? So we know that the diameter is just twice the radius. So CJ figured out, well, this is just pi times 6.8. Really? They're both exactly the same. Doesn't make a difference what you choose. No matter what, you're going to get that your circumference is, Xavier?
42.7.
And rounded to the 10th, we just stop at that 42.7. And label, look for it in your radius or your diameter. We use meters. Whichever route you take doesn't matter. If you do the math right, you get to the same result. These are real. This is the one reason why I keep using some stuff from Pearson, our old, like back when we used digits. Their examples are real. So these are actual famous coins, and they're real sizes. So these are in millimeters. So when we're talking millimeters, guys, we're talking small. We'll talk, I think, tomorrow, really, really large. But these are centimeters, right? So how do you convert centimeters to millimeters? Is it? Yeah, so this 1 centimeter is 10 millimeters. So to talk about 60 or 76 millimeters, that would only be this far. So that's the distance around it, though. So that's probably close to the coins that we have. If you think about distance around a quarter, how could you figure out distance around the quarter? Well, yeah, but if I only have a ruler. Andrew?
Find the diameter.
Now, okay, so I could calculate, or what if, just like a wheel, I took my quarter, I laid down my ruler, I stood it perfectly straight up, I start at a start point, and then I roll it until it ends up perfectly straight up.
Just think you could do it with a Sharpie, just put one point there.
Yeah. So, if you can't calculate, or if you don't want to, or whatever, you can do circle work by just some manipulation. I can't bend my ruler, but I can roll my circle. So, Hayden, are you trying to help me through on this?
No, for Degata, I got C equals 21.
You probably forgot to double. Who gave me that number? How'd you get that? How'd you get that number? Check your calculation again, Andrew. This is wrong. Erase it. If you wrote down the 42.7 and you blindly followed it, thank you to these guys thinking critically. If I double this, that's the same as 6.8. And if I double this, that's the same as 6.8. When I multiply by the pi or by the 3.14, we get 21.36. I think you accidentally doubled again. Whoever gave me that doubled twice accidentally. We only doubled once. So this should be 21.4 it would round to. Check your work. If you actually calculated the 42 value, check your work and make sure you fix whatever was off. So now we want to talk about how wide are these coins, because I want to compare, are these coins bigger or smaller than a quarter? Because that's our base unit of currency for coins. Most people, if you have coins, you probably have quarters. If you're going to the arcade, at least.
Never been to an arcade.
Ever? There's some cool ones around
Have you
town.
guys ever been to Dave and Buster's?
No.
Okay, I don't know if that counts as a real arcade. That's not like,
Those cards, it's weird.
yeah, arcades are like, it's just a place with games, like console games. These are not arcade games. We'll talk at lunch or something. With all of these, if given circumference, how do I find diameter? Let's build a new formula. Now, I know you guys, the more that we do this, you're like, oh, it's another formula to memorize. No, it's not. It's another formula to save you time and save you effort and save you work. So like on your homework, when you're trying to calculate diameters, it'll be convenient if you have a formula to figure it out. So on your paper over here, let's write out, we know that circumference is pi times diameter. Now, if I wanted to get the diameter by itself, what do we have to do to that?
Wouldn't you write the circumference number, but wouldn't you?
For any situation. So say we don't know circumference yet.
You would.
So look up here. Algebraically, how is something attached with diameter?
How it's attached by diameter.
How are these attached to each other?
Isn't it? So pi is pretty much the outcome of it.
What operation? You're thinking too hard.
Multiplication.
What operation? Yeah. No, well, what operation holds these together?
Multiplication.
So then we want to
We want to divide.
to break them apart. If we want to keep the d, we get rid of the pi, and we divide by pi. A new formula that we can use anytime we want is to get diameter. All you have to do is divide the circumference by pi. So this is one of those situations you don't really need to write things out. All I gotta do is take this, divide by 3.14. Divide by 3.14. Like all of these, just divide by 3.14 and we'll calculate it out. So our diameter here, you got it?
Yeah,
23.26. And that'd be millimeters, same labels. For my next one, it'll be slightly bigger because the coin is slightly further around. Sure. Well, slow down a little bit probably.
Okay,
24.26. My third one here will be smaller because it's got a smaller distance around. 19.76. This is the biggest one, so we assume it'll have the biggest diameter. 25.76. I think somebody making this really liked their numbers ending in 6. And my final diameter, when I divide 69.9 by pi, we get 22.26 millimeters. So this is why sometimes it's fun to be the math teacher. This guy thought of all these numbers before he started. 23.26, 24, 25, 22, and then he threw in a random one. But he made these circumferences, or whoever designed these coins or whatever, they knew the differences because they want them to be different sizes so you can feel the different sizes of the coin. So these are each different by 1 millimeter compared to each other. So, real quick, the story of how I got a speeding ticket based off math. In my Jeep that I used to have, I had a Jeep Grand Cherokee, loved it so much, take it off-road, think it'd do anything. I put big off-road tires on it. Now the problem is when you put bigger tires on your car, one rotation, will you go further than you would have originally, or will you go shorter than you would have originally? Further, because if my stock tires were that big, and I put on tires this big, I have a larger circumference, which means I'm actually driving faster than my car thinks I am. So I'm cruising down past Ohio University, headed to actually Disney World to go on a Make-A-Wish trip for my niece, who you guys have learned about before. And I'm coming down a hill, and so is a cop, and right at the bottom of the hill, I see him, and he sees me, and we make eye contact, and he flips on his lights, and I know exactly what's happening. And he pulls me over, and he says, "How fast were you going?" I said, "I was going 60, like, I forget what I said. I was like 62, 63, something like that." He goes, "No, I clocked you at 72. I'm like, "What?" He says, "Yeah, I clocked you." And I asked to see the radar. You're allowed to. You can go see the radar. So the fact that I had bigger tires on my car, my speedometer wasn't accurate anymore. I had actually changed the math of my vehicle, and I ended up with an over $100 speeding ticket because the math of my vehicle was off then. So be careful when you change tire size. You change all the math. Have a great day, guys.